Good afternoon. Thank you very much for being here today at Hannover Messe. I'm Marie-Emery Leleu, EMEA PR Manager for Schneider Electric. I would also like to thank people who are watching us now live through our first Google Hangout and YouTube sessions. Before I leave the floor to our speakers today, John Conway from Industry and Philippe Poulou from Infrastructure, let me give you a few details on a technical point of view. First, if you are in the room and you want to use the Wi-Fi, the name of the Wi-Fi will be Schneider Electric and the password Schneider-Electric. For those of you who are following us through the Hangout session, please use the chat system, and we will, through Roxanne, who is over there, we will ask your question to our speakers. If you are following us on YouTube, please use the hashtag HM15SE on Twitter, and we'll ask the question for you to our speakers as well. Thank you very much. John, the floor is yours.
Good afternoon, everybody. Thank you for coming to this Schneider Electric press conference. We appreciate you taking the time to spend an hour with us. I'm sure some of you have come here to learn about Industry 4.0. It's one of the main themes at the show here, and I will definitely be spending some time on this subject. In particular, I'll be emphasizing Schneider Electric's commitment to open industry standards, to collaborating with our suppliers, with our competitors, with our customers, to develop and deploy open de facto standards to enable the Industry 4.0 promise to be realized. My name is John Conway. I've been in automation for, I'm afraid to say, coming on 30 years now. It's actually my birthday today. I'm 54 years old today. And this is what I get to do for my birthday. So I must have done something wrong in a previous life. But actually, it's a pleasure to be here. I'm going to give a very quick introduction to Schneider Electric, talk an introduction to the industry business, and then I'll get into the subject of Invensys, a few words about the Invensys integration, and then I'll get on to the main subject, which is Industry 4.0, IoT, and what Schneider is doing. So Schneider Electric is a large multinational company, $25 billion in revenues, 4 main businesses. This afternoon, I'm representing the industry business unit. Philippe, my colleague, is representing the infrastructure business unit. And between us, we're a little over half of Schneider Electric's business. When I say industry, I mean automation and control. That's our business. We are a global player in the automation business. We have revenues of 5.6 billion euros. And we essentially have 1/3 of our business is systems and solutions, 2/3 is products. So very nice. It's about the right mix, I believe, for our business. The system solutions gives you customer intimacy and lets you feedback what you need to feedback into your best-in-class products to make good products. We're in multiple segments, everything from heavy oil and gas process, continuous process control, through to discrete manufacturing, machine builders, packaging, food and beverage industry, etc. Most customers, pretty much all customers, have some Schneider Electric products somewhere in their facility. We may or may not know about that, because a lot of our products actually flow through a very widespread distribution network. But we're a well-known brand within the automation business. Next slide, please. This slide here, very complicated. I will not spend too much time on this. It essentially has 2 axes, a horizontal axis. We have products right from the level 1 field device level, instrumentation, push buttons, contactors. Level 2 at the control level, programmable logic controllers, etc. We have our systems, a combination of hardware and software that runs the systems. We have systems for our OEM machine builders. We have systems running refineries, the Foxborough DCS system. We have safety systems also controlling the safety in those refineries. And of course, with the Invensys acquisition, we acquired a very healthy leading software business, which is a critical element of our Industry 4.0 strategy as we move forward. And that brings me to the subject of Invensys. Essentially, traditionally, historically, Schneider Electric was more of a discrete manufacturing company. With the acquisition of Invensys, we are present in the continuous process control industries. We acquired the company just over a year ago now. We've had a very busy year doing a lot of work, a 50-person team carrying out the integration. 10,000 employees are fully integrated inside Schneider, inside the systems, Schneider Electric email, etc., etc. We have one unified management structure, combining Invensys and Schneider Electric employees, a unified management structure, and we actually have unified R&D teams, and we are starting to converge the roadmaps for our automation systems and products. We had quite aggressive cost synergy targets, which we are on track to meet. And now we are starting to see revenue synergies. And I'll just give you one example here of this is the Reliance Jamnagar refinery in India. I apologize for the pronunciation, I'm sure it's wrong. It's the largest refinery in the world, in fact, and Invensys was the supplier of the DCS and Triconic safety systems. And we leveraged the Invensys trusted advisor relationship to convince Reliance on the next phase of the refinery extension to use Schneider Electric low voltage and medium voltage equipment. So a very good example of the two companies coming together, automation and control. The trends, industry trends, the medium to long-term outlook for automation is very good. There's many things that are driving that. These are the main ones. Investments in infrastructure will continue in the future. In mature economies, we have a lot of aging control systems that have to be upgraded. Increasing regulations, whether that's the pharmaceutical or the food and beverage industry, whether that's the oil and gas industry, increasing regulations is a growth driver for the automation business. But more importantly, this one here, volatility. We're seeing volatility. It's not just things going up, it's things going up and down over short periods of time. And we're right in the middle of that right now with the oil price, which has declined 50% in the last 6 months. And the euro is going down and the dollar is going up. And it's actually a complex time right now in business. And it's a complex time for our customers, and they have to adapt their production to this volatile market. And I think that is probably one of the biggest use cases for the industrial Internet of Things, for Industry 4.0, is to allow manufacturers to be much more flexible in the way they produce, in what they produce, and allow them to respond very quickly to these changing volatile conditions. Next slide, please. Having said all that, we see the industrial Internet of Things as an evolution and not a revolution. And for two basic reasons. First, our customers hate revolution. They've invested hundreds of millions of euros in automation and control systems. They do not want to change them. They want us to help them evolve them. So by the nature of industry, very conservative, it's an evolution. It's also an evolution for us because we have been pushing this since the mid-90s. In the mid-90s, we started introducing Ethernet into our control systems. We started embedding web servers inside our control systems. We call this our transparent factory. At the time, we released the Modbus TCP standard as an open standard, so we allow anyone to implement Modbus TCP on Ethernet, and it still today is the most widely used protocol on Ethernet because it's very, very simple. So really, an evolution, not a revolution, but like a steamroller, it's moving forward slowly, but it will not stop. And the promise for industry is smart. We talk about smart connected products. I'll come back to that in a minute. Smart connected products we supply to our customers. They make smart machines, smart plants, and those smart plants operate in the context of a smart enterprise. So we no longer just optimize a plant floor. We optimize multiple plant floors and the supply chain that links them together. Okay. Cybersecurity, I won't spend too much time on this. I'm not an expert on cybersecurity, but what I will say, it's one of the biggest questions that end users have with the whole Industry 4.0 industrial Internet of Things. They are very concerned about cybersecurity. We are seeing more and more cybersecurity attacks. So as suppliers, we have to reassure our end users and address this properly. You have to address it in your design process. It's not something you add on at the end. You must address it up front. And Schneider Electric, of course, is doing this. And we are supporting we are pushing very hard the development of the 62443 IEC standard for cybersecurity. We also have inside Schneider Electric, was part of, in fact, the Inventors acquisition, we acquired a small group of consultants providing cybersecurity consultancy services to end users who want advice on how to best implement the automation systems in a cyber-secure way. Next slide, please. Sorry. So, this slide, two messages on this slide. I've already touched on this message, Internet of Things, a pioneer. I've mentioned we've been working on this since the mid-90s. But the message here is not to say this is Schneider, we're a leader. That's not the message. The message here is that Schneider Electric is committed to open industry standards, and we have been since the mid-90s, pushing very hard for the industry to develop and implement open standards, because that's the way that we can get on with our real business of providing value to customers. And one of the challenges of Industry 4.0 and industrial Internet of Things is there are still some standards that have to be developed. When the car body comes down a production line and shows up at the paint shop and says, "Paint me red, please," that exchange, "paint me red," we can hard code that today. That's not a problem. But if we want to develop a standard, an interoperable standard, that exchange of "paint me red, please" has to be standardized. And there's things like that are still missing today. And again, Schneider Electric, we are fully behind, and we will collaborate with our customers, with our competitors, to put in place those standards. So stay on that slide again, please, Marie. Go back. It's okay. Now, the good news is we're not waiting for standards to arrive. There's lots of things we are doing in this area today. Now, when I talk about the industrial Internet of Things, there's the notion of Internet, there's the notion of the things. And when we talk about things, we talk about smart connected products. Essentially, electronics, embedded electronics, getting cheaper, more powerful. It's becoming very simple and straightforward to embed electronics in field devices. And essentially, the intelligence is being distributed more and more into these smart connected products, okay? And that's a key area of development for our best-in-class product business. We call it innovation for simplicity. We innovate to make things easier for our customers. Here are a few examples that you can see on our stand if you have time to visit us. Dynamic QR codes, very simple idea. When for example, a variable speed drive stops on a production facility, quite often you'll get some obscure error code on the screen and you'll have to go find the documentation to figure out what to do. With this dynamic QR code, the operator shows up, he flashes the code with his smartphone, with his tablet, and he can be connected directly to either to an expert in our customer care center, or he can go straight to the page in the documentation that tells him how to recover from the problem. So a very simple example of these modern technologies that allow us to reduce, in this case, reduce downtime of a process drive. Mobile apps, using smartphones and tablets, very useful in commissioning to actually quickly connect to devices, see the status of the device, perhaps change something on the fly. Very good for operations, very, very practical, simple things. Wireless and less wire, that's a complex subject, wireless, but in simple terms, when you install an automation system, the biggest cost is the installation cost, running wires, running cable tray. You will never eliminate that completely, but you can reduce it, and you can make things more simple. And that's a big focus for our best-in-class product business. And finally, embedded intelligence. Again, the example here is, I use the example of our drives. We are embedding inside the drive. For example, we can embed the pump curve inside the drive. And what this means is we can monitor where the drive is running on the pump curve. And if we detect that the drive is running most of the time on the wrong part of the pump curve, we can correct that. And that's very important. In simple terms, if you run a pump in the wrong part of the pump curve, you wear the pump out very quickly and you consume a lot of energy. It's not very efficient. So these are very simple things, embedding intelligence inside the products in the field to really bring some sort of tangible benefit to an end user. Next slide, please. And we're very proud. You can see this on our stand again, the M580 Programmable Automation Controller. We received the Control Engineering Award, Controller of the Year Award for 2015. What we've done with this controller, it's the culmination of our 15 years of work on Ethernet. We actually have Ethernet embedded in the backplane of the controller. So I don't know if you're familiar with controllers. You have a backplane, you plug input-output cards into the backplane, you plug intelligent modules. That backplane is Ethernet. Okay, what that means is our customers, our partners, they can actually develop their own modules and plug them into that Ethernet backplane. Because it's Ethernet, it's an industry standard that everyone understands. And while the actual requirements of Industry 4.0 are not fully clear today, we're Industry 4.0 ready, and we can develop very simply, our partners can develop modules to integrate inside an Industry 4.0 architecture. Next slide, please. I won't spend much time on this slide. I've kind of covered most of these points. You'll get a copy of the deck afterwards. It's just a few examples of the different things we're doing inside a drive. And at the end of the day, it's about improving production efficiency. Next slide. And please, as I said, go to our stand and you can see our Wonderware demo. We're doing a demo on our Smart Glance software, which is essentially software running on mobile devices, giving you real-time access to information from controllers, from your MES systems, from whatever, okay? But that's what we talk about smart connected products. Now, in terms of what are we doing in the cloud, we're doing several things, but again, here's an example I quite like, because it's something that is not the classical big data analytics. It's something actually quite different, but again, very pragmatic and extremely useful for customers. It's what we call engineering in the cloud. If some of you are familiar with automation systems, when you develop an automation system, you end up in a room like this with all the hardware at the back there making lots of noise, and you maybe have 10 engineers sitting down, programming and configuring for maybe 6 months, 9 months. Away from their homes, very expensive, not very efficient. Now Schneider Electric, we can actually put their system in the cloud inside one of our data centers, and they can work on the system remotely from different countries. So now different engineers from different countries can work on the same system. They can do more thorough and more complete testing. And as well as reducing the cost of configuring the system, the real benefit is when the system finally ships to site, it's of a higher quality level, and the commissioning is much quicker. So we actually shorten the commissioning time of a large, complex automation system by using the cloud. Next slide, please. This is a more complex example of this is an acquisition of a company we made a couple of years ago called Solvit, an Australian company. Remember artificial intelligence? We had a lot of talk about that probably 15 years ago. Actually, artificial intelligence is mature today. And here's an example of artificial intelligence, which is just another form of advanced analytics. What these guys do is, we provide decision support systems for complex manufacturing operations. This is an example of a mine. And if you think of a mine, what is a mining operation? It's maybe 10 different mines extracting iron ore. It's a complex network of a rail system going to a port, and it's boats coming in to the port to be loaded up with iron ore for shipment to customers, okay? That supply chain is actually, it's actually managed as one supply chain, and it's quite a complex thing to manage. And what happens if a train breaks down? What does the operator do when a train breaks down? Which order does he cancel? Can you get the iron ore from another mine? What is the impact on throughput? What is the impact on profitability? It's a very complex problem. So what we do is we model that supply chain. We do a detailed model. And then we solve, when the train breaks down, the operator can say, train's broken down, what do I do? The model runs, and 15 minutes later tells him, you should do this. And this is why, and it explains why he should do that. So it's not a black box. It says, you know, cancel this order, cancel that order. That will optimize the profitability of your operation. And here's why. Now that actually, what's unique about that is you cannot do that with conventional linear programming techniques because the model is too complex and would take 50 hours to solve. Using artificial techniques, it takes 15 minutes. And that's the big breakthrough. And that's a typical application that I think is, I would call that the industrial Internet of Things, Industry 4.0. So I've come to the end of my presentation. We'll have questions at the end, so you can ask questions. But I would encourage you to come visit us on our stand in Hall 11, booth C50. You can see the modern Bodycon 580 controller with the Ethernet backplane. You can see the Altifar process drives that I spoke about with the dynamic QR codes, the embedded intelligence. And you can also see the Invensys systems that are now fully Schneider Electric, the FoxPro DCS, the Triconix safety, and of course Wonderware and the Wonderware Smart Glance demo that I spoke about earlier. Okay? I think we hold the questions to the end, right?
Thank you very much, John. So yes, please hold your questions until the end of the presentations. We'll move directly on to Philippe Poulou, our Infrastructure Marketing and Communications VP.
Okay, thank you, Marie. Good afternoon, ladies and gentlemen. I'm very glad to be here with you and trying to try to explain you what we're doing for smart grids. And smart grids, whether we are industry, utility, distribution utility, or even citizens, are going to impact or are impacting already the way we operate, the way we behave. And I would like to show you concrete examples on how connected technology can help to solve the issues and the challenges of the smart grid. So I will briefly introduce Schneider Infrastructure, and then I will give you those concrete examples and present the major stakes we have in the electricity distribution aspects. And then I will finish with a couple of innovations we have that are enabling all these technology to happen. So Schneider Infrastructure, we are present, medium voltage energy distribution is present in all segments of industry. Buildings, data centers, wastewater, all of these industries, mining, minerals, are using medium voltage energy and need distribution systems. Obviously, distribution utilities are the enabler of all these medium voltage energy to be distributed and brought to the factories. In terms of footprint, we are very balanced between mature countries and developing countries, new economies. With approximately 50-50. Next slide, please. So, making a smart grid a reality, we are providing solutions from the upstream, the generation, into the transmission and distribution aspects, but also on the consumption side. And that's what I would like to show you. The main drivers impacting the electricity, medium voltage energy distribution, first of all, the aging of the networks. The infrastructure is aging. In mature countries, in new economies, constraints on the budgets are high everywhere, or almost everywhere. And that means we cannot renew as fast and with as much capacity as it would be needed. On the other end, we see the rise of renewables. Fossil fuels are not available forever, or will not be available forever. So we have to move on, and we are moving on to renewables fuels. On the other end, this is also accompanied by more stringent regulations. For instance, in Europe, we have 3 directives with reductions in increase in efficiency, increase of renewables, reduction in carbon emissions. So all this mix is really pushing towards renewables. On the other end, there are still some investment. So the sector is growing. There are some investments. This is mostly because we are expecting a huge increase in energy consumption. See, projecting by 2035, plus almost 40% of energy consumption overall. Next slide, please. So in this context, what are the main challenges of the utilities? Well, first of all, is ensuring the grid stability despite the complexity. So I don't know for how long you can tolerate or think it's bearable to have a shutdown of electricity, a blackout. Depends on what is your activity, but most of them it's critical, so it's intolerable. Apparently, in the US, the public says it's tolerable for 6 hours, which is approximately the length your smartphone can last. And after 6 hours, it's totally out. So, but anyway, this is needs to be restored much quicker for industries or for even for areas where people live. So why complexity? Well, basically, in the past, you could imagine the generation and the electricity network with large centralized production units coming down, top down, in a unidirectional flow. Now you have renewables dispatched in the whole territory. So the flow is multi-directional, bidirectional in most of the place. And on the other hand, renewables that are much less controllable than traditional energies. So the stability, the control of the grid is much more complex than it used to be, and it's going to increase as more and more industries are also going to produce their own energy from renewables and maybe inject that into the grid. So another one, please. So here, for instance, I want to show you a solution we have provided to one of our customers. This is in Spain with 9REN, which is a company, an engineering company providing this solar farm. So one of the challenges we have in renewable energy is the cost of this energy and the complexity to control these sources that can be very scattered. So here we have provided a control system that enables to control almost 600 locations with one operator, one control system, and it enables to be much more efficient in all the planning, the maintenance planning, and the control system of the energy. So you see that with that, we are turning an energy which was difficult to control and to monitor into an energy which is much more dispatchable. Another aspect of the smart grid is the microgrid. So microgrids are growing and growing. It's a way to isolate a part of a grid, and the better example is what happened in physical islands. So here we have an example in the Faroe Islands. So we have built, along with our partner Dong, we have created a complete integrated system that enables to manage the grid. So it means basically monitoring all the sources of energy, all the consumptions, the stability of the grid. So thanks to all the connected solutions, we're able to manage this microgrid. And this is leading to lower fossil fuel consumption to produce this electricity, higher stability, and cheaper electricity in the end. Another challenge is to increase operational efficiency. So, for instance, in Europe, we need to increase efficiency by 1.5% per year. So we need to do that not only at the end of the chain with the consumers, but also in the process. So one of the solutions we have is to be able to increase the flow of energy in a given network, which means running closer to the limit of the network. So for instance, here we have a solution that is in a city in the Netherlands. Unfortunately, we're not allowed to tell the name of the city, but that's a large city in the Netherlands. We have installed a self-healing grid So self-healing grid is a grid that is enabled to detect automatically some defects and reconfigure in order to minimize the impact of the defect. So here we were able, there was a cable which was cut by a storm or physical incident, and the network was restored in 18 seconds. On average, this kind of restoration would have taken 2 minutes before we installed the system. So you see, we're able to operate closer to the limit of this grid, which enables to increase the capacity of energy that is transiting through the grid without putting additional cables and switchgear. Another aspect is the generation of energy. So here in this reaping power plant, we have installed a system which enables to manage the energy of the plant and also to control the whole process through our structureware software suite. So basically here, by monitoring the various production areas and monitoring the flow of energy, we're able to be much more efficient. And you see there was a saving of over 20,000 tons of CO2 emission. Another aspect we have in making smart grids a reality is to manage the demand. So we have seen that we have on one side the generation, the injection of renewables. On the other hand, to manage the grid more efficiently. The third pillar for us is to manage the demand. So we have here an example, another one, please. So how do we handle peaks? So you know that electricity consumption is not linear in the day. In the morning, when everyone is getting up and using a domestic appliance, there is a peak. Then there is another peak at the end of the day when everyone is coming home and also managing the home. So those two peaks, or more peaks depending on each profile, if we weren't managing the demand, they would need additional generation. By managing the demand, we are able to shave those peaks and to avoid to generate more electricity. How do we do this? For instance, with Energy Pool, we have aggregated several industrial customers that are consuming energy, and their capacity is, they have a huge capacity to consume energy, but also to shed some load at a given time. So we manage the process for them not to be too much impacted by this reduction of the energy consumption at one time. So that's our know-how, and it enables us to really cut the consumption of these customers by 20–30% compared to their peak consumption. This gives a virtual generation capacity for which we don't need to build a new power plant or to increase the generation because we're able during this peak period not to consume this energy. So, well, I showed you how our connected technology enabled to monitor, manage the grid in a smarter way. Just in a nutshell, basically the areas we have been talking about: grid operations, which is manage the network efficiently, operate closer to the limit of the network; renewable operation, which is to make renewables dispatchable and more usable; microgrid, which helps to limit the dependency on fossil fuels, but also increases the grid stability; and last but not least, the energy services that are helping to bridge the demand and the supply, talking together more in a smarter way, more cleverly, in order to minimize the need for generation. So all this also works because we are building devices that are already ready to be connected. So here we have two devices. First of all, our PremSet switchgear, which is a totally new isolation media, and it's revolutionary from this standpoint because it's a solid insulation instead of gas or vacuum insulation, so it enables to be much more compact. It's also a design that is already built in to be connected to the control systems. And mineralized grid is a transformer that can be adjusted while being on load. So it enables long reconfiguration when you want to adjust your transformer. So it enables, again, to be much more efficient in the way that the grids are used, and for them to be used in an optimal way. So you can discover these on the booth. They are there. So I think, I hope I've really illustrated how these connected technologies can help to manage the grid in a smarter way. But if you still have some question, I guess we are going to answer all those now. Thank you very much.
Thank you, John. Thank you, Philippe. I guess we have a few questions from the room and probably from the Hangout. Our colleagues from Spain and Turkey might have some questions from their journalists. Maybe we'll leave time for them to type the questions, and we'll take a few questions from the room. Any question?
Okay. Yes, I'm Sal Spada from ARC Advisory Group out of Boston, Mass. And this is a question for John, because you had a complicated slide. I think it was number 3 or something like that. And you had up there products, talking about the machinery target market, and you had a product called Machine Structure, which is a whole software product line that's targeted toward machinery. And I also thought there was a companion product for the process industries, and it was called something structure, and I can't remember the plant structure. But you did not have it up there. It looked like it was omitted, and I'm wondering if that has been, something's changed as a result of the acquisition within Vensis. Yeah. Okay.
Is my mic working? Yes. Nothing has changed. That's an edit error. Okay, and I apologize. Plant structure should have been up there. In fact, if you like, with the action in Vensis, we acquired Foxborough, but Foxborough is a large DCS, continuous process control. We have to have an offer. We have an offer called Plant Structure for the hybrid process segments, formerly based on our PLCs and Cytec offer. Mm-hmm. With the acquisition in Vensis, we are going to integrate that with Wonderware and take advantage of the Wonderware batch process control functions to, in fact, enhance the Plant Structure offer. So that is absolutely an error. I just want to be clear on that. And that, in fact, that business is now all organized under our process automation division, who are responsible for both the DCS, the Triconics, but also the PLC offers and the plant structure offer for the hybrid markets.
Okay,
so we're reinforcing plant structure, and I apologize for it not being on that slide. Huh?
Oh, it just seemed like there was omission, and it had been such an initiative over the past few years.
And it still is.
Okay. And then you had made a distinction in your product line that you had a line of programmable automation controllers. Is that strictly for the hybrid industries that you're targeting that? Because I've looked closely at your machine structure line, and the packs are not actually included in that particular portfolio of products. So the packs are more like the M580 series are more targeted toward the hybrid?
The packs are more targeted towards the hybrid industry. That's in terms of targeting. They end up everywhere, okay? Yeah. You know, life is not simple. We have OEMs that use them on machines. But the primary focus is on the end user business as opposed to the OEM business, the machine builder business, which has a different concerns and care about. So the end user is more long-term investment, slow evolution, protect my investment. The OEM is more about best in class, the latest innovation for my new generation of machines. So slightly different business requirements. Huh? Okay.
But is it still more targeted toward process applications?
Yes,
or,
yes.
You know, okay.
Than machine, yes.
Than machinery. Okay.
That's correct, yeah.
Great. Okay.
Okay.
Any question? No? I think we have a few from the Hangout.
We have one here for Philippe. Philippe, do you believe microgrids are the future of smart grids?
So microgrids are an answer to specific needs. So areas that need to be to have a certain stability that can be disconnected. They are not the future and the unique solution, but they are one solution among others. And what we see is growth, maybe by 3 or 4 times within the next 5 years, something like that. But it's not the solution. It's one solution which is very adapted to specific areas, and there is not one single solution that is going to make all the smart grids. It's a bundle of several solutions.
Any other question?
Should I introduce myself? John, this is another question because you made a statement in your presentation about transparent factory. And I recall when it was introduced back in the mid-90s or something like that. And am I correct in saying that you think this is the genesis of basically your IoT evolution that we're seeing today?
It basically was the same idea. It was about incorporating Ethernet open technologies inside the real-time hardware and making information available to high-level business, the level 3 and level 4 systems. That was the fundamental idea behind it.
Has there been any issues that, I mean, has the transparent factory solution that is underlying all of the Ethernet technology that you have today, has it had to change or has there been some sort of requirement to change to accommodate some of the IoT requirements that people are expecting today?
No, I mean, the fundamental principles haven't changed. Of course, the protocol has evolved. We integrated Modbus TCP with Ethernet IP, ODVA, to try and gain more acceptance for the standard. So it's been an evolution. Again, it comes back to evolution, not a revolution. But the basic idea has been the same. I think what is changing though today, and what is making the whole IoT and Industry 4.0, I wouldn't say dream, but the wish a reality is the decreasing cost of electronics, embedded electronics. That's which is allowing us to connect more devices to Ethernet, to IP connections. And then the advances in software, okay? The advances in software in terms of analytics and big data. So that wasn't really happening 15 years ago, and it's happening now. But the standards are still missing, okay? And so it still has to evolve. Huh? And so we still have a lot of work to do there. And again, Schneider Electric, fundamentally, that was what was behind Transparent Factory was openness, industry standards. And Schneider Electric is committed to that, and we will continue to push for more open standards to make the IoT and Industry 4.0 a reality. Okay.
All right. Great. Thank you.
Any comment? Okay. You can take the microphone over there.
Is it? Oh, it is on. John, we have another question following the comment about converging roadmaps and that type of thing following the integration of Invensys. Have any of the offers become redundant, and is anything being streamlined? Is the question on the Hangout.
Yeah, actually, one of the attractions of the Invensys acquisition was the fact that there was very little overlap between the Schneider Electric offers and the Invensys offers. Schneider Electric being more on the process side, and we being more present on the discrete and hybrid. So really no overlap. Overlap in one area, I would say on the software side between Wonderware and Cytect, but in fact, in reality, it's not a problem because Cytect, in terms of geographies, it's different geographies. So when I say convergence of roadmaps, I'm not talking about streamlining offers, I'm talking about integrating offers together, making it easy for when our process automation people sell a Foxborough DCS system that they can pull through the PLCs as well, okay? a better integration between RPLCs and the Wonderware software to enable all the batch control functions for the hybrid system. So when I talk about convergence of roadmaps, I'm talking about converging the offers to create new value. We're not talking about eliminating existing offers, because there's very little overlap.
Thank you. Any other question on your side? No? So I have a few through Twitter. First one will be probably for John as well. It's a journalist from Spain, I guess, Logística Manutención, who is asking, do you think the revolution in IoT comes from the internet? Which seems to be obvious. Maybe you can say a bit more about how we experienced this within Schneider.
Well, actually, I think what is driving the IoT Industry 4.0, I think there's three things. Let me get this right. There is software. Well, let me start with it. There is IP connection. So connecting devices to the internet. Although even that, I would argue with, it's not just about Ethernet. There are some other protocols around the edge that it's not just Ethernet, but it's essentially, it's about connecting devices to a network, and in particularly Ethernet, IP connection. But it's about embedded electronics. It's about the cost of embedded electronics becoming cheaper and control being distributed into the field. That's the second aspect, and that's actually that has a lot of promise in terms of distributing the control architectures, more robust systems by distributing them. But it has some challenges in that today a lot of the control software is very much controller specific, and we have to start thinking about a distributed control architecture, which is a different way of thinking. And the third thing is software, as I spoke earlier, big data analytics. That is the other aspect. So it's not just internet, it's software, IP connection, internet, and embedded electronics. That's my opinion.
Thank you very much. We have another question from Twitter coming from our Turkish team who is attending the session through the Hangout with journalists in Istanbul, so we can say hi to them. And this would be more for Philippe and the infrastructure business. Are you aware of the electricity shortage we faced in Turkey on March 31st, 2015?
I'm not aware of that specific one. Maybe there is a little bit of information, or the person wants to
no more information. More. Maybe if you follow us in Istanbul, you can be a bit more precise on what are you expecting. I think it will be coming out from the chat. But maybe you can say, no, maybe not on this specific one, but maybe you can say a bit more about the self-healing solution with how much we can, well, Phil mentioned the reduction of the time of the shortage that this solution can bring. Maybe you would like to say a few words about this?
Well, basically, this solution enables to identify where we have an issue, and as we have information from the status of the network in several points of connection, the system enables to identify very quickly, when we say quickly, it's a couple of seconds, an alternative road, and then for the energy, and then is able to monitor the various devices automatically to reconfigure the system. So it enables to very quickly bring this type of functionality in the distribution system. In the past, this type of functionalities were working only for large transmission systems, and now more and more we are able to have automated reconfiguration on the lower voltage levels. So really, what it's doing is bringing closer to the consumption the systems that used to work in the transmission and the higher voltage levels.
Okay, thank you very much. Any other question or comment from the room? You do?
Ludovic Nachourier from the Direct Industry magazine. I have a question for Mr. Poulou. I'm a bit curious about this solar farm in Spain. Could you explain a bit about what you implemented so that you could control basically 600 points from a single location?
Yeah. Well, basically, we have a system we capture all the data on each of the locations, and our system is enabling to see the status of the various locations, and then seeing the whole flow of power, and managing that, mixing that to the demand, and also enabling to plan and select the maintenance operations and how we are going to stop or start the various points. And this is done in a central point. It's also done in a remote way, so we don't have to go and set each single point. So it's basically connecting the data, analyzing the data, and in order to make the best technical decision. So it's the connection plus the software that enables to do this aspect.
Thank you. We have some precisions on the question from Istanbul. So Roxanne, if you'd like to tell us more.
Yes, certainly. So the story is 6 hours of electricity shortage nationwide in Turkey on the 31st of March, with traffic lights out, traffic jams, people stuck underground in transportation systems, people stuck in lifts. And the question is, what could be the solution for this kind of problem?
Well, here what we see is that it's an illustration of the fact that the stability of a network is not something that is granted, and that is really the fact of a constant balance. I cannot answer on the specific. I don't know what caused this, these 6 hours blackout in Turkey. Well, generally, when you have this systemic, it's a conjunction of several causes or one major cause. So I cannot comment on this specific one, but it's more this event is more the proof and the sign that stability of the networks needs to be monitored. And it's not something that is granted. So we need to implement systems that are more and more automated in order to anticipate this crisis and make sure we have when we have a fault, a defect somewhere, that we are able to reconfigure and manage this fault as quickly as possible in order to avoid that.
Thank you. Any? Okay, just let me.
This is again for John. I have one question with regard, you had a mining slide up in the, talking about some of your AI technology, I think it was called Simple IT and all that in the mining industry. Now that you've acquired Invensys, do you see any opportunity to have a synergy between some of the process applications within the mining industry and basically market the product into the mining where you've had success primarily from the kind of the HMI or the production management side? Is there any plans for moving in that direction? Because Invensys hasn't historically been in the mining industry at all in terms of the process side.
Yeah.
So.
Yeah, and we have a strong presence because of the Cytec acquisition 10 years ago now. So I'm not sure I fully understood the question.
Well, the question, I'm sorry. The question I'm trying to understand is: do you envision that you could bring the Invensys product into the mining industry? Does it have any?
Yeah, there are some mining processes where DCS is a better solution than a PLC-based solution. Some large continuous. I'm not a mining expert there, but there's some solutions that DCS is a better solution. So yes, our mining team is we have a mining segment team that manages all the mining global accounts, and they clearly are looking to pull through the DCS solution where a PLC-based solution is perhaps not the right one. So yes, that's one of the synergies we've identified, is to pull through offers in both directions, the pulling through Invensys and Invensys pulling through Schneider. That's one example. Mining example where we can use DCS. Yeah.
Okay, great. Thank you.
Any comment? No? Okay, so I'm going to check whether we have more questions from Twitter. We have great pictures of you. So I can't see any more questions from Twitter or from the floor. So I would like to thank everyone for joining us today, especially our friends in Spain, Barcelona, and Istanbul in Turkey, and everyone who might have been following us through our YouTube live session. The hashtag HM15SC will remain available over the Hannover Messe, so don't hesitate to ask any questions and we'll address them to our speakers and they will answer you properly. Thank you very much. Thank you, Philippe. Thank you, John.
Thank you.
And thank you.
Thank you.
Thank you.